about data frame and column. The objectives are we construct the columns, we subset the columns, we add or replace columns, we subset rows, we sort the rows. You would first run the classroom setup. Then what we would do is that we would read the da.paths.events in the delta format, and we are displaying the data frame. The column expressions. A column is a logical construction that will be computed based on the data in a data frame using an expression. We construct a new column based on existing columns in a data frame. So first is we import it from the pyspark.sql.functions, the import call, and we can print the eventsdf.device, eventsdf square bracket device, and or we could reference it by call bracket device. Scala supports an additional syntax for creating a new column based on existing columns in a data frame, and it is $device. Now we can create complex expressions with existing columns, operators and methods. We can add to columns, we can sort it in descending order, and we can even cast the column as integer. Here's an example of using these column expressions in the context of a data frame. So here what we are doing is that we are filtering the column, and with the column purchase revenue, we are creating a new column called purchase revenue, which is actually the column multiplied by 100 and is cast as int. The average purchase revenue is the e-commerce.purchase revenue in USD divided by e-commerce.total quantity, and we sort it in descending order the average purchase revenue. So in the data set, what we will have is that two things, the purchase revenue and the average purchase revenue. Let's see whether we are having it or not. Yes, we are having these two columns which are additional. So the with column produces these two new columns. We can subset the columns by doing a select which lists the columns or column based expressions. We select using the user ID and the device. Here also what we can do for the columns is that we can select the columns as well as we can do an alias. The geo.city is being aliased as city, and the geo.state is being aliased as state, and we can display them, and so we are having user ID, city and state. The select expression, so it selects a list of SQL expressions. So here what is happening is that we are having user ID and the device in certain macOS and iOS as Apple user. So if the device is in this list of macOS or iOS, then it is an Apple user. So we have true, false and all these things. We can drop, so it returns a new data frame after dropping the given column. So we can drop these columns, user ID, geo and device. We can also drop the column e-commerce, so that is also there. We can add or replace columns. So what is happening is that with column we are creating a new column mobile, and we are creating and this mobile column is being created using the column device which is in iOS or Android. So what is happening is that if I go here, we are getting this new column which is a mobile column, and it gives a true or false whether the device is an iOS one or Android one. So the purchase quantity, and here also what is happening is that we are creating a new column purchase quantity, but here this column is equal to the e-commerce total quantity but is cast as int. So if I go down here, we'll see that this purchase quantity is an integer. The with column renamed, it returns a new data frame with a column renamed. So what is happening is that here we are renaming the geo column to be a location column. So the geo column has city and state. So what would happen is this geo would be replaced by the location. So once we display it, you can see the location has city and state and the geo column has been replaced by the location. We can subset the rows. We can use data frame transformations to subset rows. We can filter using the e-commerce.total item quantity which is greater than 0. So that is how we are filtering it. The e-commerce.purchase revenue in USD which is not null, also we can filter it in this manner. Here what we are doing is that we are filtering with the traffic source which is not equal to direct and the column device is Android. We are dropping duplicates. Here it returns a new data frame with duplicate rows removed, optionally considering only a subset of columns. Here we are just getting all the distinct columns, and here we can do the drop duplicates so as to find the only the distinct user DH. The other things might be equal, but here we are concentrating only on the user ID. If the user ID is the same, then we are dropping and selecting the distinct ones. Limit. So returns a new data frame by taking the first n rows. So that is in this cell we are limiting and getting the 100 rows. We can sort the rows. Here what we are doing is that we are sorting in increasing order, that means in ascending order by the event timestamp. But in descending order, what we have to do is that we have to mention the descending. So call event timestamp dot desk, or we can do by a set of columns by order by, and we can mention a list of columns as we have mentioned here, the user first touch timestamp and the event timestamp. Or we can do a combination in which we can do a sort and we can do a column that is a user first touch timestamp in descending order but the event timestamp in ascending order. And then we clean up the classroom. So this completes the lecture on data frame and column. Hope you liked it.